Hello students, in this video we are going to continue with calculation of residues. This is part 2. This is the next problem. In this problem we are going to find the residue at z equal to 0 of the given function is 1 plus e power z by z cos z plus sin z. See, in my previous video I have posted a problem. In that first we calculated the poles and we got the residues at the poles what we calculated. But in this problem they didn't ask you to find the pole. They have given a point. Actually this is a pole of the given function, and in that pole alone we have to calculate what is the residue of this problem. Okay. For this problem, we are going to use this result. If you have a term like numerator and denominator, we can use the formula residue. We have to check first h of a is not equal to 0 and k of a should be equal to 0. If these two conditions are getting satisfied, then residue of f of z means the whole term. F of z at the pole a is h of a by k dash of a. In my previous video, we have used this method for the problem what we saw in that video. So we are going to use this one here. Here, h of z is the numerator 1 plus e power z, and k of z is the denominator z cos z plus sin z. When we substitute z equal to 0, h of 0 is equal to 1 plus 1, which is equal, e power 0 is 1, 1 plus 1 is 2, which is not equal to 0, and k of 0 is equal to, obviously 0 plus sin 0 is 0, 0. So these two conditions are getting satisfied. So we can apply that formula. What is the formula we have? The formula is residue of f of z at the pole. Here it is 0 is equal to h of 0 by k dash of 0. For that first we have to find what is k dash of z. What we have k of z? K of z is equal to z cos z plus sin z. We have to find the derivative of k of z, that is k dash of z is equal to this one. We have to differentiate with respect to z. Here in the first term we have two terms in terms of z cos z. So என்ன formula use பண்ணனும்? uv method. u into dv plus v into du. That formula we have to apply since it is a product of two functions in terms of z. So z அப்படியே வச்சுக்கலாம். cos z differentiate பண்ணுங்க. It is minus sin z plus cos z அப்படியே வச்சுட்டு z பண்ணிங்கன்னா 1 plus அடுத்த termல ஒரே ஒரு function தான். So அதை மட்டும் differentiate பண்ணா போதும். cos z, which is equal to minus z sin z. Cos z plus cos z, it is twice cos z. After differentiating, we have to substitute z is equal to 0. Am I right? So therefore, k dash of 0 is equal to, when we take 0, this term will become 0 plus 2 into cos 0, which is equal to 2. The formula what we have is h of 0 by k dash of 0. K dash of 0 now only we got as 2. H of 0 already we got, that is equal to 2. So 2 by 2, after cancellation the answer is 1. So residue of f of z at the point at the pole 0 is 1. So 1 is the answer for this problem. Is it clear? The next problem what we have is we are going to find the residue of 1 by z square plus a square the whole square at z equal to ai. So pole கொடுத்துட்டாங்க. Actually இதோட power பார்த்தீங்கன்னா z square the whole square. Total of 4. Okay. So 4 poles இருக்கும். அதில் ஒரு pole mention பண்ணியிருக்காங்க z is equal to ai. In the pole we had to calculate what is the residue of the given function. This one. Okay. So what I am going to take is, first I am going to take the given term as f of z. Okay. So let f of z is equal to 1 by z squared plus a squared the whole square. This one I am going to factorize because I am going to split this for this pole. Okay. So how I can factorize this? What I said. So poles calculate பண்ணனும்னா denominator term equal to 0 கொடுங்க. Whole squared equal to 0. So therefore z squared plus a squared equal to 0, which implies z squared equal to minus a squared. So which implies z squared is equal to minus 1 க்கு I squared கொடுக்கலாமா? I squared a squared. Therefore, z is equal to plus or minus root of I squared a squared, which is equal to plus or minus IA, that I can rewrite as plus or minus AI. So z is equal to plus AI ஒரு pole, z equal to minus AI ஒரு pole. Total 2 poles தான் வருமா பாருங்க. The power is 4, right? So AI is repeated 2 times and minus AI is repeated 2 times. So it is a double pole. Both are double poles. Okay, double pole na என்ன meaning? Twice வருது. So ரெண்டு தடவை இந்த value வரும். Z equal to AI, Z equal to minus AI. Power பார்த்துக்கோங்க, Z square the whole square. So power is 4. So we are in need of 4 poles. Okay, so this pole is repeated twice and this pole is repeated twice. On the whole 4 factors we 4 roots we got. So 4 poles. Okay, so it is a double pole. Single pole, simple pole இருந்தது அப்படின்னா previous problemல பார்த்த அந்த h of z by k of z formula is applicable. But since it is a double pole, that method is not applicable here. For double pole or multiple poles, we have to use this one. Let A be a pole of order m which is greater than 1 and f of z is of the form g of z by z minus a the whole power m. So a தான் pole. So pole இருக்க term மட்டும் denominatorல வச்சுட்டு மீதி எல்லாத்தையும் numerator கொண்டு போயிருங்க. அதை g of z ன்னு consider பண்ணணும். So நம்ம எதை போலா வச்சிருக்கோமோ அந்த factor மட்டும் தனியா பிரிச்சு denominatorல இருக்கணும். அது தவிர rest whatever we have no together you combine that as g of z. So g of z by z minus a the whole power m இருந்தது அப்படின்னா we have to make sure g of a is not equal to 0. So the residue of f of z at the pole a is equal to g power m minus 1. m minus 1 அப்படின்னா g of z m minus 1 times differentiate பண்ணதுக்கப்புறம் zக்கு a ன்னு கொடுக்கணும். We will do this using the problem, okay, by m minus 1 factorial. So this is the format which we are going to use for this problem, okay. So நம்ம first இதை split பண்ணி எழுதிக்கலாம். 1 by z square plus a square the whole power 2 கொடுத்துட்டேன்னா, so this can be what are the factors we got? Plus ai minus ai. So plus ai அப்படின்னா minus ai கொடுக்கணும், z minus ai. ai is the pole means இதுக்கு negative sign z minus ai, that is a factor. Minus ai அப்படின்னா z minus of minus, so it is plus z plus ai, that is one pole. ரெண்டுமே double pole, so இங்கேயும் whole squared வரும், இங்கேயும் whole squared வரும். Totally power 4. Okay, so I repeat, we have splitted this using the poles. If it is plus ai means z minus ai is the factor. If it is minus ai means z minus of minus ai, that is z plus ai is the factor. So நம்ம residue பார்க்கறது எந்த போலுக்கு? plus aiக்கு. plus ai வர்ற factorனா இந்த factor தான். So keeping this alone in the denominator, we are going to rewrite this as 1 by z plus ai the whole squared whole divided by z minus ai the whole squared. You know how we are splitting this? So நம்ம எது pole சொல்கிறோமோ அந்த pole இருக்க term மட்டும் நமக்கு denominatorல இருக்கணும். மீதி இருக்கதெல்லாம் நம்ம numeratorக்கு change பண்ணி வச்சுக்கலாம். numeratorக்கு change பண்ணுறோம் அப்படின்னா without affecting the given term only, we have to just rewrite it, okay. Just like that, we are not able to take that to the denominator. Just rewriting that without affecting the given term. Okay. So this term alone I am keeping in the denominator. This I am going to rewrite that as 1 by z plus ai the whole square. So this is now g of z. g of z by z minus a the whole power m. So it is a double pole. Double pole means m is equal to 2. So what should be the formula here? The formula what we had there is z power m minus 1 a by m minus 1 factorial. Here m is equal to 2. It is a double pole, right? So m minus 1 is z power 1 of a, g power 1 of a by 1 factorial. 1 means one time we have to differentiate g of z. We have to differentiate this. Then after that we have to substitute z is equal to a. That is the procedure. Am I clear? So we have to differentiate first one time and we have to replace z by a. So what is our g of z here? G of z is equal to 1 by z plus ai the whole square. So what is our g dash of z? G dash of z is equal to this one. When I differentiate 1 by x squared, what I am getting when I differentiate this with respect to x, which is equal to x power minus 2 plus 1 by minus 2 plus 1, which is equal to x power minus 1 by minus 1, which is finally minus 1 by x. So when we differentiate this, I'm sorry, this is not differentiation, d by dx of 1 by x squared. So d by dx of x power minus 2. When I differentiate this, this is minus 2 x power minus 2 plus minus 2 minus 1. So it is minus 2 x power minus 3. I'm sorry, here I confused with integration. Okay, so the differentiation is minus 2 by x power 3. Okay, so this is the differentiation here. So minus 2 by, instead of x, here it is z plus ai power 3. So minus 2 by z plus ai power 3. This is my g dash of z. After differentiation, we have to substitute z as, what is the pole we have? ai. So ai we have to substitute. Therefore, g dash of ai is equal to minus 3 by, minus 2 by, I'm sorry, minus 2 by ai plus ai power, ai plus ai power 3. So minus 2 by 2 ai the whole power 3, which is equal to minus 2 by 2 power 3 a power 3 I power 3. I power 3 can be written as I squared is equal to minus 1. So I power 3 is equal to minus I. Minus 2 by 2 power 3 a power 3 minus I. Minus minus we can cancel. 1 2 we can reduce. So it is 1 by 2 squared, that is 4 a cube into I. This is my g dash of ai. After that, in the formula, that divided by 1 factorial. So finally, the residue of f of z at the point ai is equal to 1 by 4 a cube I whole divided by 1 factorial, which is equal to 1 by 4 a cube into I. Am I right? So which can be written as 1 by 4 a cube into I. What is 1 by I? 1 by I is equal to minus I. Complex number, we are not able to take that in the denominator. We have to take that to the numerator. How we can take that? 1 by I into multiplying and dividing by its complex conjugate. What is the complex conjugate of I? Minus I. So minus I by minus I we are multiplying. Minus I by plus into minus 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 I squared. Minus I by minus of I squared value is minus 1, which is equal to minus I by minus into minus plus 1. So finally 1 by I is equal to minus I. We are not supposed to take a complex imaginary part in the denominator. Okay. So this is equal to minus I by 4a cube. Is it clear? The next problem what we have is find the residue of cot z at z is equal to 0. In this problem also we are not, they didn't ask you to calculate what is the pole. They have given one pole. At that pole we have to find the residue of the given function. So given function is f of z. F of z is equal to cot z. Cot z I am rewriting as cos z by sin z. Okay. So since it is a single pole, it is not a double pole, they didn't mention anything. So it is a single pole, and we can rewrite, we can take this as h of z by k of z. What is the formula for calculating the residue? Residue of f of z at the pole A is equal to h of a by k dash of a, right? So h of a means here it is h of 0 by k dash of 0. H of 0 means cos 0. What is cos 0? 1. First we have to calculate k dash of z. K dash of z is equal to differentiation of sin z, right? So cos z. Then k dash of 0, which is also 1. So 1 by 1, which is 1, that is the answer for this problem. This problem is quite easy. Am I right? Thank you.